Today, we're jumping into a really cool piece of chemistry that, honestly, feels a little bit like magic. It's a story about how combining two things can create something way more powerful than you'd ever expect.
I mean, think about that question. It just seems to break the basic rules of math, right? But in the world of chemical engineering, a team of researchers stumbled upon exactly this kind of wild result. Okay, let's get into it.
So our story starts in a super practical place, the engine. We're all looking for more sustainable ways to power our world, and that includes the very oils that keep our machines running nice and smooth.
The big goal here is to create high-performance lubricants from renewable stuff, like plant oils. But there's a huge problem. The crazy heat and pressure inside an engine, well, it just completely tears these eco-friendly oils apart, and way faster than the traditional petroleum-based ones.
The main bad guy in this story is a process called oxidation. And a really simple way to think about it is like rust on metal. It's basically a chemical attack that breaks the oil down, turning it all thick and sludgy and pretty much useless. So what this really means is that because of oxidation, these green lubricants just don't have the lifespan they need to be practical. This is where the chemists come in with a special class of additives designed to protect the oil.
And that brings us to the heroes of our story, antioxidants. Their entire job is to fight off that oxidation process, protect the oil, and make it last longer. So researchers decided to test out a couple of different kinds.
All right, so in one corner, you've got BHT. It's a smaller, kind of nimble molecule. And in the other corner is MBDBP, which is much larger and way more stable. Now, on paper, they've both got their strengths, but they also have some pretty big weaknesses. BHT, well, it has a bad habit of just evaporating when things get hot. And the bigger, MBDBP, it can be a little slow to get to work.
So naturally, the researchers decided to put them to the test. They added each one, all by itself, to a new plant-based oil. Then they cranked up the heat and put it under a ton of stress to see just how much longer the oil would last. First up was BHT. And hey, the results were pretty darn good. Adding BHT boosted the oil's resistance to oxidation by 235%. A really solid performance, but there was a catch.
Now, this is what's so fascinating. During the test, the researchers could literally see the BHT just vanishing from the oil. It was evaporating and forming little crystals on the lab equipment. And that meant, of course, that it was losing its power over time. Okay, so next up was the bigger molecule, MBDBP. And just as they expected, it was way more stable. It didn't evaporate at all. It gave a performance boost of 230%. So, very similar numbers to BHT, but without the disappearing act. So at this point, the conclusion seems pretty obvious, doesn't it? The bigger, more stable molecule is the clear winner. Case closed, right? Well, this is where the story takes a completely unexpected turn.
The researchers decided, hey, let's just try one more thing. They asked a simple question. What happens if we mix them together? And the result? Well, it wasn't just a simple average of the two. It was something else entirely.
And this chart from the study shows it all so perfectly. Okay, so on the far left, that's BHT all by itself. On the far right, that's MBDBP on its own. Now, see that dashed line? That's what you'd expect their combined performance to be, just adding them up. But the actual results, those really tall bars in the middle, are just blowing way, way past that line.
So just how much better was it? At the perfect mixture, these two antioxidants, working together, boosted the oil's lifespan by a staggering 546%. That is more than double the performance of either one of them on its own. I mean, this is a textbook case of the whole being so much greater than the sum of its parts.
This is what true chemical synergy looks like. And it just begs the question, how on earth is this happening?
So what's the science behind this magic? Well, the leading theory is absolutely fascinating. Remember BHT's big weakness, that it evaporates? The researchers think that the big, bulky MBDP molecules are basically creating a molecular shield around the smaller BHT molecules. This physical interaction keeps the BHT from escaping, keeping it in the oil where it can actually do its job. It's literally teamwork at the molecular level.
And if we want to get just a tiny bit more technical, what these antioxidants are doing is acting as radical scavengers. They hunt down and neutralize these super reactive molecules called radicals that cause all the damage. So by keeping both antioxidants in the mix, they can basically tag team the problem with incredible efficiency.
Okay, so this is a really cool lab result for sure. But what's the real-world takeaway? Why should we really care about this synergistic boost?
Well, this matters because it gives us a clear roadmap to making green lubricants that don't just match the old petroleum-based ones, but can actually blow past them in performance. This is a huge step forward in making sustainable tech not just a nice idea, but something that's truly practical and durable.
You know, the researchers themselves summed it up perfectly. The performance of the mixture is better than the best performance of each individual additive. I mean, that is the very definition of synergy, and it's such a powerful principle in science.
And that kind of leaves us with one last big thought. This was discovered in lubricant chemistry, sure, but it really makes you wonder, doesn't it? How many other simple combinations of materials, of ideas, of technologies are just sitting out there waiting for us to find a result that isn't just 1 + 1 = 2, but 1 + 1 = 5, or maybe even more?